Hello everyone. Let's find the probability distribution of number of heads when we toss two coins. On the right hand side what you see is the solution, and on the left hand side is the implementation. So I have to find out the probability when we toss two coins, the number of heads. So let's first create the sample space. So when we toss two coins, the favorable outcome can be the following: head head, where both the coin is generating, each coin is generating one head; head tail, tail head, or tail tail. So the total number of favorable outcome would be 4. How do I do this in context to Python? Well, first what I have done is that I have created one list called coins that contain head and tail. Why I did this? Because I want to pair them together. I have to pair it. See, this is a pair. So how do I pair them? Well, for that reason I'm going to give a call to the module called itertools, and this module is going to provide me a function called Cartesian Product. Yes, this product function is actually a Cartesian product where you're going to do the Cartesian product of these two items. And how many times you are going to do the Cartesian? Since you are going to toss two coins, so that's the reason I've written over here repeat equals to 2. Had this been only 1, then you have got only one head and one tail. But we have gone for two coins to be tossed, so for that reason the Cartesian product will be in the form of a tuple, and the tuple will be having two items. And finally each tuple will be inside a list. And that list is what I'm going to print right over here. So just like the way we can see the sample space over here, why don't we do the same thing right over here now? And here it comes. Look at the output. This is my sample space, which is equivalent to the one which you are seeing right over here. So in each iteration it is doing a Cartesian product, and it is creating a tuple, and all these tuples are put together within a list, and that's what we are printing. And that's how we are getting 4 favorable outcomes. Alright. Okay, that accomplished step 1. Now we move to step 2. So in step 2 what we are going to do? Well, we have to define our random variable x. And how do I do that? Well, for that reason what we have to find is the number of head that each outcome is going to provide. Or you can say so that for each favorable outcome you are going to assign one value. That the way also you can think. So if you look at the first outcome, it has got 2 head, so I've written 2 over here. The second one 1, the third one is also 1, and the fourth one doesn't have, so it's 0. So you can think in this way that each of these outcomes we are going to assign one number. Hence the random variable can have 0 or 1 or 2. So these are the values that the random variable will come across. Now how do we accomplish this when it comes to program? And that brings us to step number 2. Let's look at this statement. Well, you can very much aware that this statement means list comprehension, and that's the reason why I stored the initial list over here, so that I can iterate one by one. And while iterating, my probability is to find out number of heads, so I can go for count. That means in the first iteration it picked up this tuple which has got 2 head, hence the output should show me, well, output will show right over here, but first I'm storing that the value 2 inside my list. Then it will pick up this tuple which will have 1 head, it will store 1. It will pick up this tuple that will also have 1, and the last one will have 0. Hence if I run my code now, I'm going to see the following result, as you can see right over here. So this has got 2, this has got 1, this has got 1, and this has got 0. So as I said that the outcomes we can label them by some numeric value, and that's what we did right over here. And that's what I was showing over here as well. And that was the portion of step 2. So now we move to step 3, where we are going to find the probability of each of these values. But keep one thing in mind, over here we have got 1 twice, but in context to x I cannot write 1 twice. I have to make it unique, so it would be only 1 time. Now how do I achieve this part? so that finally I have got 1 rather than twice. It will be only one time, and that's what I did right over here. In fact, what I will do is that I will uncomment this whole portion because I've already calculated the probability value of each also, and so I will show them one by one. Okay, right over here it is. So okay, what we do, we will comment this portion and just show you that how did I accomplish the following stuff. So let me clear this, and now let me run the code to show you that the total outcome was 4, but I have been able to reduce it to 3. Why? Because the 1 was twice. So how did I manage this? Well, let's come over here. As we can see, in the list we saw that the outcome is going to have 4 items, so I calculated the length over here. Okay, I calculated the length over here, and that's what I printed. So length is right over here. We are getting the value 4 because of that reason. And now comes the most challenging part of the story, which actually took a little bit of time for me to solve, is this part, to get the respective value, to generate the value, okay, the value of each of the source items, that is over here. So how did I accomplish this? If you look at this line very minutely, you will find that this is a dictionary comprehension. Why it is dictionary comprehension? The reason is each of these value, let's consider as a key. So when x equals to 0, what is the probability? So when x equals to 1, what is the probability? When x equals to 2, what is the probability? So this 0, 1, 2, in context to Python, let's consider them as key and the corresponding other value. So that means we are creating a dictionary. Hence, if this is a dictionary, then this is also a dictionary, this is also a dictionary. So we combine all these 3 dictionaries together, we will get one list, and that list is going to contain dictionary. Well, I need to tell you one thing. If you are solving it from the perspective of only statistics, then all these things are not going to be countable. But if you are doing it in the practical part, then definitely these are the points that you have to keep it in mind, because ultimately you have to execute that in the program. So for that reason, list comprehension in the form of list and in the form of dictionary is going to play a very crucial role. So let me show you how did I accomplish this. So when we calculated the value of each of these, so 0 means we don't have any head at all. Such scenario will happen 1 out of 4 times. We will get at least one head, that will happen twice. So it will 2 upon 4, and it will be we will be getting one head that also is there, so that will be 1 upon 4, and hence we are getting the respective value. That is, when it is 0, the value would be 0.25. When it is 1, the value will be 0.50, and when it will be 2, the value will be 0.25. So this is what we need to derive, and that's what I need to show right over here as well. So how did I generate this key value pair? So let me show you over here. So this is my x. So x is already having this numbers, right? This numbers is there already in x. So that's hold this numbers. So now what I'm doing is that I give a call to the set, because we know that Python comes with a data type called set, and we can use that so that I will get the unique. So this 1 will be considered, this 1 which is written twice will be considered one time. So now what is happening is that it is picking up the first item, that is 2, and then what we are doing is that, look over here, I went for a key, and remember the outer portion is wrapped within dictionary, curly bracket is there. This one was wrapped within third bracket, so it was a list comprehension. So I will consider that to be the key, and now I will be doing the division part as well, like what I did over here. So how do I get this 1? Well, I counted the value of x. So what is there in x? The x is there, x is holding 2. So how many occasions are there where x will be 2? There will be only one time, right? So this is going to be 1 upon total count. Total count is 4, which we saw over here as we printed this 4. So 1 upon 4 comes right over here, and that gives us 0.25 that got stored as x is 0.25. And when this x is what? The value of x is 2 actually, right? It picked up, if you think this 2, then it will be then 2. Okay, let me print the value, then it will be easy for you to understand what I am trying to mean. So let me run the code now, and let me clear the screen once again to show you the final output. Look, so at first it picked up the 0. So when it picked up 0, that will be again the same thing as we saw over here. The 0 will have 1 upon 4, that is 2.5, 0.25, right? So when it picked up 1, that will again 0.50, because you can see over here 1 means how many occasion. One means actually you're talking about this scenario where we have got this one over here. Okay, this is the way it's working. Actually it is taking up one item at a time. That's the reason it's happening, but actually this is the thing that goes. So there will be scenario where there will be no head at all. That scenario is there, 1 upon 4, which will be 2.5. A scenario is there where we'll be getting one head at least. That scenario will be getting 2 times, which will be 0.25. so that is what basically is over here. So 2 refers over here is the following one. That means sequentially it's coming actually. Okay, so it would be like 0 1 2. So this one I'm considering this one rather than considering this as, put this one over here. So 1 upon 4. That means there will be one occasion where you will be getting one head. That will be 1 upon 4. That will give me 0.25. And there will be 2 means I have a scenario where I will be getting 2 head. That would be 0.5. So the way it has arranged in the sequence order, I would have written this one above, would have been good. Then it would have been easy with this one, right? I hope you understood what I meant. Again I'm explaining. So there will be a scenario when there will be no head. That means such scenario is there when there is no head right over here. So this is going to be 0.25. There will be scenario where you will be getting both the coin will have a head. That scenario will be there at least one time. That means it will be also 0.25. and there will be a scenario where you will be getting head from each of these coin. That will be 2. So that will give us 0.5. so that's what you are saying. Fine, and that's how I have calculated this particular portion with the help of dictionary comprehension. And finally, to verify that whether this is all correct or not, we just kept on adding. Probability of 0 is 1 by 4, probability of 1 is 2 by 4, and probability of 2 is 1 upon 4, and finally we'll get the number as 1, and that means this particular solution is correct. And that's how we get to this particular format. So from this we really understood that we can easily transform our program, or we can transform the solution of this probability into a program part, and the way this is done with the help of iterative tools. And we also came across how list comprehension and how dictionary comprehension are going to play a crucial role to give me the solution, that what would be the probability when we toss 2 coin in context to the number of heads. So this is the outcome of the following program. Okay, that's all from this video presentation. See you soon. Bye bye.